Okay, fantastic. Okay, so good day, everyone, and welcome to the Astro4Dev Full Moon Mashup. So this is not usually our usual meeting times, but we also try to accommodate everyone from different parts of the world, especially our guest speakers. So we're very flexible with the time. We just try to keep it as close as possible to the full moon since they're called full moon mashups. Um, we are really excited to kickstart our 2026 Full Moon Mashup series and with this conversation, and it's very wonderful to see everyone join us from different parts of the world. If today is your first time joining us, welcome, welcome, welcome. And the Full Moon Mashup series is basically designed to be a relaxed conversational space where we can pause, reflect, and also exchange ideas on how astronomy is being used not only just to explore the universe, but also to support people, communities, as well as connections here on Earth. So today's session focuses on radio astronomy, intercultural collaboration, as well as science diplomacy, and how these ideas come together in practice through Astronomy for Development projects. So I am Dr. Joyful Mdhluli, and I'm with the IAU Office of Astronomy for Development. I coordinate our flagship projects here at the OAD and also lead these Full Moon Mashup series. I'll be your host for today's discussion, and we're delighted to be joined by project leaders from the Radio Astronomy for Development Intercultural Innovation and Outreach initiative that we supported in 2025. So, if you're not familiar with our office, the Office of Astronomy for Development is a joint project between the International Astronomical Union as well as the South African National Research Foundation that is supported by the Department of Science, Technology and Innovation. We were established in 2011 and we are based in Cape Town, South Africa, at the South African Astronomical Observatory. So the mission of the OED is to help further the use of astronomy, and this includes its practitioners, skills, as well as infrastructure as a tool for development in every country. And this is done by mobilizing the human and financial resources that are necessary in order to realize the field's scientific, technological, as well as cultural benefits to society. This is primarily implemented through funding and coordinating projects that use astronomy as a tool to address issues related to sustainable development. And for today's discussion, the discussion is centered basically around one of the projects we funded in 2025. So, as we know, astronomy has always been a shared human endeavor across cultures and history. People have always looked up at the same sky, asked similar questions, and as well as told stories that help us make sense of the universe itself. But in the modern world, astronomy now also offers something else, a way for people to come together across borders, across cultures, as well as political contexts, using science as a common language. And then in our case, we're using astronomy as a common language. So today we're exploring the idea, we're exploring this idea through the lens of radio astronomy, a field that is inherently collaborative and it's often an international necessity. And often international by necessity. And it is well suited to shared learning as well as data-driven exploration. And the Square Kilometer Array Observatory is one of these examples as well. So the project we're focusing on today, the Radio Astronomy for Development, Intercultural Innovation and Outreach, brings together educators, students, as well as institutions from different countries together. We have Greece, we have China and Pakistan, and they come together to learn, to build, as well as to explore together. So what makes this especially powerful is that it's not just about the science, but it is also about intercultural encounters that emerge along the way, where students collaborate across continents and teachers are navigating this different educational contexts, as well as participants seeing one another from not through stereotypes, but through a shared curiosity. And while this project is rooted in education and outreach, it also speaks to a broader idea many of us are thinking about, which is science diplomacy. So science diplomacy doesn't always happen in government meeting rooms or formal agreements, but it also happens at the grassroots level. And this is when people collaborate, they build trust, and also maintain dialogue through scientific work. And projects like this one here shows how educational collaboration can quietly contribute towards science diplomacy. and by fostering understanding, encouraging cooperation, as well as building long-term relationships between societies. So in today's discussion, we'll hear directly from the project leaders and how this intercultural collaborations have unfolded in practice, what worked, what challenged them, as well as what surprised them that they didn't expect would come out of this collaboration. So with that context in mind, I'd like to invite our speakers to introduce themselves and briefly share what their role in this project is. And as we move into the conversation, I encourage everyone else to think about not only how science itself, but also about the human connections as well as the science that makes this whole possible. So with that said, I'd like to hand over to our guest speakers. And if you could all just provide a short introduction of who you are and what your role is in this project, and then after that, we'll get the conversation started.
Good, thank you.
Thank you. Yeah, we'll start with you, Eleni.
Okay, great. Thank you very much for the great invitation and the great introduction. We're very honored to be here with you today. We are the local management teams of radio, as you see our logo behind us. I am Eleni Vardoulaki. I'm an astrophysicist, the PI of radio, and the chair of the National Astronomy Coordinators, Education Coordinators for Greece. So I'm also the co-PI of the Citizen Science Project, Radio Galaxy Zoo for the Evolutionary Map of the Universe survey, where we make bridges between citizen scientists. We ask for their help in order to identify and classify complex radio sources from big surveys and train our models to do this automatically and more efficiently. So we create robust catalogs and we create bridges not only between the general public and scientists, but we try to create a common language between scientists and scientists from different fields. I will pass over to Hongming.
Hi, thank you, Eleni, and thanks, Joy. I'm Hongming. I'm basically professionally saying I'm a assistant professor now at the Xi'an Jiaotong and Liverpool University, which is a China UK co-founded uni. Weird, but it's happening. AMR. In terms of work, I echo Eleni that I'm co-PIing the Radio Galaxy Zoo EMU and co-PIing the radio project that we're talking about today. So I really appreciate this activity, to be honest. We can talk about this later. That it's not only about. So now I'm kind of interested in using astronomy as a pathway to not only know my own country, but also to use it as a bridge to communicate between cultures. So we can talk about this later. But yeah, I learned that in the last year when this project is going.
Hira, would you like to take over?
Thank you very much. Thank you very much for this invitation and very generous introduction of us. Hello, everyone. I'm Hira Fatima. I'm astronomy researcher and educator from Pakistan. I use astronomy as a tool to promote education, equity, and empowerment. And I have been working with International Astronomical Union Office of Astronomy for Education as chair of National Astronomy Education Coordinators team for Pakistan. So when I started my journey of astronomy education, I used to work with the students only. Then I realized to reach more and more students every year, I started working with teachers. And with the support of many international organizations, for example, IAU OAE, OAD, Royal Astronomical Society, and Lars Kumbers Observatory, I organized several trainings for students and teachers. Few years back, I was only involved in optical astronomy, and I worked with the LCO, Lars Kumbers Observatory, as their global sky partner, and I used their robotic telescopes in my education and outreach activities. But when I extended my research from optical to other parts of spectrum, so I developed my interest to introduce universe at different wavelengths to the students and teachers, and this led me to become the part of education and outreach team of Radio Galaxy Zoo Citizen Science Project that Eleni just mentioned. And that led me to be the part of radio, and now I am one of the national representatives of radio in Pakistan. Thank you. Faisal, would you like to join?
Yeah, so I'm Faisal. I'm co-managing radio sites of Pakistan side of the radio project, and I mainly work with Lahore University of Management Sciences as resident scientist, and I also work with industry as a CTO in one of the companies called W3 Technologies. My main research is in cosmology and astrophysics. Since 2013, I have been teaching courses of astronomy and other STEM areas in universities, different universities of Pakistan, and at the same time, I have been involved with outreach activities in the country related to astronomy, and I have been writing some of the outreach articles as well in the newspapers, basically to advocating for promoting astronomy in Pakistan, because unfortunately we are still in very early stages of developing an astronomy infrastructure. So I'm just pushing that it's not only about doing astronomical studies, it's about capacity building of this country as in science and technology and advancing the civilization, because it's not just about development, which people say development is a whole spectrum. It's not about human development and technological development. You are developing capacity for your country to face the challenges of the future as well. So if you have brilliant brains working, they can do a lot of good things for your country. So that's the passion which has brought us together, and we are trying to share the science and technology as a tool to bring people together and build capacity in each of our areas.
Thank you all. Yeah, it's really great to have you here today. So there are four key discussion points that I sort of kind of identified that I'd like us to talk about or around, but that doesn't mean that we're limited to these four discussion points, and everyone else is more than welcome to ask questions and, just have a conversation. So I won't ask them directly at anyone within our guests, but then I'll just ask, and whoever feels they want to respond to it or add on to what the other person has said is more than welcome to. But then this discussion points is firstly, we'll look at the design and the implementation of the project itself, but also the experiences across cultures, how that was or is, if it's still going on. And then also how science acted as a bridge to having intercultural connections. And then lastly, also, how do we then move from education to diplomacy? And like I said, so this is not supposed to be an interview between me and our guest speakers, but more of a conversation with everyone. So everyone else who's part of the audience is more than welcome at any point to raise their hand if they want to contribute towards something or leave something in the chat. You're more than welcome to do that. It is more of a conversation than it is anything else. So yeah, I think with that said, I think I'd like to move on to the first point that I highlighted, which is the design and implementation. So like, how was the radio project structured to ensure that there was meaningful intercultural interaction? And what considerations were made to include the different languages, the different contexts, as well as the educational systems? Because I can imagine that these are three different contexts and languages and educational systems. So how did you guys work around all of that to make it all swerve and fit in together?
Yeah, I can go ahead and answer that. So our idea for proposing radio in the first place came from our very good collaboration within the Radio Galaxy Zoo EMU program. So through the years of collaboration, we realized that we all have common goals. We like to study the universe, we like astrophysics, we want to understand the nature, but we also want to educate the next generation so they can take over after we are gone. We need to create this continuity. We are all educators and science communicators. So we designed this program to address a very big problem that is in all schools in all three countries, that astronomy is not being taught at the official curriculum. Not even in Greece. It used to be, but it used to be when I were a kid, but it's not anymore for at least 20, 25 years. So we wanted to address this, and we designed a project that was going to teach basic astrophysics, the basic principles of astronomy, astrophysics, and radio astronomy, along with citizen science, to children of the age of 12 up to 17, 18, including their teachers. So we are also educating the teachers so they can form units like astronomy teams in their schools and take over, continue this program on their own. We didn't want to leave it only at the theoretical level. For us, it's very important to show that astronomy is not just reading a book and looking through an optical telescope at the stars, that there is a full plethora of data that we don't see with our eyes. Okay, so we discussed about the electromagnetic spectrum and everything we see, and because our expertise is in radio astronomy mainly, we introduced this topic that it's not very well known in our countries. Okay, despite the square kilometer array being the very big thing that is coming now, there are teachers and children that have never heard the word radio astronomy, and they don't know what radio astronomy does. So we wanted to change this. We wanted to also introduce the concept of when you do astrophysics, you have to deal with data, so you need some skills, and one of the skills is computing, so you write code. And if you're interested in writing code, you could become an astronomer, or you could work in an institute or on a telescope, you know. So we try to give career paths to the kids. Now they are at the age where they're gonna choose their career path. And the last component was, well, there are two components. One of them is projects, little projects, theoretical or practical. For example, their connection to the night sky, write an essay. How do you feel about the night sky? Here is the application Stellarium. Tell me your favorite object and discuss about it. Tell me how it looks in different wavelengths, with an optical telescope, with a radio telescope, with an X-ray telescope. Do you understand the physics behind this? Discuss it. Download some data, use Aladdin, the platform, and compare the Milky Way in radio and optical. Why are they different? Discuss this. So we are posing these questions. We gave them a set of 14, if I remember correctly, projects. One of them was to construct a radio antenna, a small radio antenna with cheap materials that they can either buy or recycle, like a satellite dish that they might have, and a satellite finder, so they can detect radiation from the sun. So this way they understand that the sun, yes, we see it with our eyes, but we can also detect it at radio wavelengths. And this component, the project was we had in mind that we will collaboratively propose these projects and give them to all the students and teachers from the three countries. The same with the seminars. We performed seminars. We have a common curriculum, and we taught them the basics of astronomy and astrophysics and radio astronomy. We invited them to use our platform, the Radio Galaxy Zoo Emu, and become citizen scientists, get inspired to help astronomers and other scientists to do the research. And the last component is the intercultural exchange. For us, it's very important to teach children and their teachers that through collaboration, we can achieve much more. So this was a very critical component of our proposed project. We haven't done it yet. It's scheduled for the 7th of March. It's an online workshop where the students from the three countries with their teachers will present their projects, whatever they chose from this list we provided, or something else. Maybe they made something on their own. They can present it. We will do some talks. They will also talk, and we will have this exchange. And also we brought together some schools from the three countries because they asked us if they could collaborate with each other. So we created that bridge for them. And for us, this is very important. It touches all the points that you very well mentioned, and it's very important for diplomacy. We are living at a time where we need to push forward and inspire people to collaborate and work with each other and lower their inhibitions, let's say. So to have open mind and be able to see beyond nation, to see beyond race, beyond gender. For us, it's very important, and we hope through our project, which is a pilot project, to inspire new projects and to have a continuation of this with further funding.
To add to Eleni's point about the intercultural and having the astronomy outreach beyond borders, one of the interesting things which happened with us in the online cohorts is that we announced the project for Pakistani schools, but since it was in Urdu is also is understood as in a spoken form in India as well. And the situation between India and Pakistan, there was like war last year, and we saw registration. We saw lots of numbers from +91, and like wow. So we just thought like more than about half the students who registered, students and professionals and parents who registered were from India. So we had and we had these sessions, and they attended as well. Some of they have also submitted assignments as well. It was really encouraging to see that people are, despite in these tense situations, people are coming together to understand astronomy or radio astronomy, to learn something, because sky is for everyone. It's not sky has no borders. We have borders on land, we have borders policies on land, but we don't have borders on the sky. So that was something really encouraging, how people actually, it's particularly young kids, they participated and they submitted projects and assignments, instead of just registering for this. So that was really encouraging, I think, and that was one of the highlights of all this program for us particularly. So yeah.
I want to add something. So this project is really close to my heart, and there are several reasons. I can, of course, mention few of them. So when I was a kid, nobody told me that I could be an astronomer or astrophysicist. And I want to tell students, I want to tell this generation about the opportunities that exist. And when I studied astronomy, when I started studying astronomy in university, I remember people even used to ask me, can you tell me, can you predict me my next month, my next year? So they don't, so they were unable to differentiate between astronomy, astrophysics, and astrology. So I really wanted to create that awareness. Also, I encountered this perception that astronomy or astrophysics is not for developing countries. It is something that developed countries do. So I wanted to tell them that no, as developing countries can do astronomy and astrophysics, and even you can use astronomy for development. And this is where my thinking and the mission of OED really resonated, and the team members really wanted to use astronomy for development. So I wanted to show students and teachers that astronomy is a gateway science for STEM. You can use this for STEM, and I'm very lucky that I have this team with me that opened this new window, radio astronomy, for students and teachers. And we wanted to show them that the things that you use, that you study in theory, you can do that in practice. You can do something that is really hands-on. You can build your own radio antennas, very low cost radio antennas, and you can use for data collection and analysis. So that was the motivation behind that. And as Eleni mentioned, that the project EMU Citizen Science Project, Radio Galaxy Zoo Citizen Science Project, it is in now more than in 7 languages. To make it more accessible, we translated that project in our national languages. And so we have so many students and teachers that are part of that project, not only from China, Pakistan, and Greece, but from many other countries. So and you asked about how we are running this project in three different countries, how we designed it. So as Eleni mentioned, that this international team came up with a curriculum that we want to teach these topics, we want to develop these skills in the students and teachers, we want to introduce them to these softwares and these data literacy things. So we designed a curriculum, but as we know that there are different education system in every country, the context is totally different. The culture, the language, the starting points, the resources they have, the barriers, the access issue, everything is different. So our team, what we did, we adopted that curriculum based on the needs of our countries. So we were like very flexible during that process, and we co-created everything. We worked with the educators in our country so that we can adopt the activities to meet the needs of local teachers and local students. So we were not like delivering the curriculum that we that this international team developed. We worked really hard on this curriculum with local educators to adapt it to make sure that we are touching the local needs. So it is designed locally, first internationally, and then adapted locally by local team for the local users. This is something. And as Faisal mentioned that our last online trainings were for students from Pakistan, from teachers from Pakistan, and we were joined by different students and teachers from different countries, from different cities in Pakistan. For example, Karachi, Lahore, and Islamabad. But as the training was in Urdu and in English, so many students from different countries where Urdu can be understood, they joined us. And even students where Urdu cannot be understood, they joined us because they know that all the educational material that is provided free of cost after the training will be in Urdu and in English, and they will have the access to the discussion groups. So I can say that I felt that it's very successful that we are not here to solve the geopolitical issues, but we created a space where everybody can join, everybody from different culture who has interest to explore the universe and interested in learning this shared neutral language of astronomy joined us. So I think, Homi, if you have something to add, please.
Wow. Hi there. Thanks, Hira. Wow, that's a great speech, I would say. But actually, I wanted to add something following your words. And I grew up in a city thing. So in Guangzhou City, perhaps you have heard about it in China. And during my past 23 years, I never realized that China is so big. Until last year, actually, I have to admit that. And exactly was because our effort that we designed the startup or the starting curriculum context, let's say in that way, we build up a starting point for us to um, merge with local needs. And for the first time in the last year, let's say in this way, last year I firstly go to a actual middle China village that everybody there are farming corns. They've been doing nothing else. And kids, they live with their grandparents. Their parents go to city for work, and their grandparents just bring up them with them. So I met these kids. I also met those kids who live with their parents who work in the city, but their hometown actually comes from villages. So they all have different education needs. And of course, urban kids, they have fancy radio telescopes that cost, let's say, 1,000 euros per set. And they know pretty much about it, yes, but yet they don't know much about radio. They have very good equipment, yet they have no little knowledge about radio. So I'm very happy and I feel grateful about this, is this provides me an opportunity to know people everywhere around and to know what they really need. Because in the very beginning of radio, we actually design a radio antenna toolkit that roughly 1,000 euros per kit, let's say in this way. And when we bring these idea to rural schools, of course they reject it. Of course they say we need cheaper solutions, we need some other solutions. So after some work, we figured out, oh, there are some wooden fast telescope models that took us, let's say, €5. So in €5, they can work collaboratively, they can chat what radio is, they can know what data collected from the radio signal can be. Let's say from the 21 central neutron hydrogen signals, let's say pulsar signals, they can chat with that. So knowledge are shared no matter in rural regions, in developed regions, or by city kids. Let's say it this way. So yeah, I can talk more, but my key idea here is I really thank this project that brings me a new window to not only all the countries we're collaborating with, but also the countries I'm living in. And also the kids, actually, those kids get involved. They got a chance to chat with each other. And that's really good. Yeah. Sorry, I think I should stop here. But yeah, I feel grateful about this experience.
Yeah, no, you all had so much to share. I'm just like, okay, you've sort of kind of covered all four discussion points. And I think before I can sort of move on or anything, I'd like to open it up to our audience and everyone else who's here. If you have any questions, anything to add on to what they've shared so far, it would be great. You can just either raise your hand, ideally raise your hand and ask the question yourself, but you can also like leave it in the chat. Um, do you have any questions?
While we wait for a question, maybe I can add something
Please
and
go ahead.
think of something. I think these kind of projects are very important. We see this from schools. The teachers tell us all the time that please do more of these projects. We really need them. Science, they don't promote science so much, and we can see how much they appreciate our effort. We wish we could also do more. And it all depends also on the funds. It's very important to have funding bodies to fund this kind of projects. It's important in all countries, not just in developing countries. In Greece, for example, I see a drop in science education. When we were kids, we learned different things. The level was a bit higher. Now, science is not in the common curriculum so much. It's considered something extra. Kids are afraid of physics, for example.
Mm.
And this is quite a shame because they can discover the world and their capabilities through projects like this. So for us to be able to bring this kind of projects to the new generation and train them so they can become the scientists of the future, we need to be supported by local governments, by international funding bodies. And we are more than happy to continue doing that. It inspires us, we love doing it, and we want to inspire the next generation.
Great. While we're still there, is there room for other people to also like have similar engagements within their countries as well? Do you have resources that they can easily access and they can implement these projects in their respective countries?
Yes, our purpose is by the end of the project to have everything online. So we are designing a website where all the material is going to be put online in the three main languages, but also translated in English for better consumption, let's say. And we have a YouTube channel where all our online seminars, because we performed online seminars, are going to be added there in the local language, but also in English. Hopefully with subtitles. It's quite a lot of work, so I don't want to promise something. But this is our intention. We want to make it as accessible as possible. And we are open to collaborations for the continuation of this project. We would like to propose, like to bring more proposals for future funding. And we had already had a discussion with a representative from India that saw the project and really enjoyed it. And we will propose something commonly in the next round with us and in India, and whoever else would like to join. This is our vision, to be able to make this as a practice, like to teach radio astronomy to schools and to teachers.
Okay. Well, I guess the two questions slash comments in the chat are basically asking about the curriculum and content you've developed for the school kids. So I'm assuming you have a dedicated website for this where people will eventually be able to access it at some point, right?
Yes, the YouTube channel is already online. It has the Greek, at the moment, it has the Greek lectures, but very soon it will also have the ones from Pakistan. And as we go, we will keep uploading. And the website is being prepared, so there we will upload any available material that we have. And of course, we are happy to answer any questions that there might be.
So I would like to add, as Eleni mentioned, that we have organized several online trainings for students. So all the trainings were in the national language. For example, I'm talking about Pakistan. So the trainings that we organized were in Urdu and in English, because there are two main streams in school education in Pakistan: Urdu medium schools and English medium schools. So our trainings were in Urdu and English. So we have created this curriculum. We have curated the learning material, tutorials, demonstrations, recorded lectures, and so many things. And all these things are publicly available. As I mentioned earlier, that in our first workshop, online workshop, we received 400 registrations, because people who know Urdu were like, okay, I want to join this. People who know English, they were like, okay, I want to join this. Even people from other languages, who can understand English, they enrolled. They didn't attend, but they got the access to all the learning materials. So as Eleni mentioned, that we are working on the website. As we compile the complete learning material, we will make it available on that website. But now it is available in our drives and publicly available links on YouTube channel. If you need anything that is related to Pakistan, you can contact me or Dr. Faisal, and we will be happy to share the material that we developed so far. So yes.
So we will also share, if you are interested in coding, we have developed Google Colab notebooks. You can easily use them, and videos also explain them. So if somebody somebody's asking, if you are interested in coding a data analysis, that will be helpful for you as well. And we will also we have also developed the manual for a low-cost telescope, as Eleni explained. So which has already been tested in a school in Karachi in theory schooling system only. It is we deliberately started from a relatively remote area and low income area, just to see if they can do it, others can easily replicate it as well with their resources. And we reimbursed, of course, from the project budget. They were able to create a low cost telescope within around like 6,000 rupees, which is around less than 20 euros. And that was able to detect, as Eleni explained, that it was able to detect radiation from the sun. And kids were very, interested in seeing the results, especially like from 3, 4, 5th grade schoolers. They were there as well, so they were also interested in seeing what is happening. So all the material will be there for the schools to use. And I believe with that low cost, even schools with like relatively less resources, they will be able to do something about it.
And I would like to add one more thing, that Joyful asked about the challenges. So I would say the learning moment. So it was not that easy, like we are telling that we are a team from different countries and we developed this curriculum and things are so easy. No, actually it was very difficult, because we have different education system, we have different academic calendars, we have different national holidays. So it was very difficult to synchronize things, but we managed. We found a way to do these things. So we developed this curriculum, and then we adapted to meet the local needs. So we executed our project in phases. Like the first phase was like this international team developed this curriculum, and in the next phase we adapted that curriculum to meet the national needs, and then we started these online trainings, because we knew that the starting points of students from all the countries are different. To take them to a common point, to a common footing, to a same footing, we did these trainings so that they can develop the basics, the foundations of radio astronomy. And when we feel like okay, they are now ready to collaborate, at this stage they will do their projects in which they can collaborate with students in different cities in their own country, or students in other countries, for example, in China and Greece. So, this way, the teachers will feel confident that they can introduce astronomy in their classrooms, and students will like, okay, now I'm not reading this thing in theory only. I can do something hands-on. I can develop my own low-cost radio antenna, take the data and analyze. And when these students work with the students from any other country, they work on a similar problem, a similar data set, a similar question, and they build upon each other's idea. They develop respect, understanding, and they feel that okay, they are part of something big, international community. So this is something that we are trying, that these students and teacher collaborate, and in the end of the project we will organize an international meeting in which all the students will present their projects. So this is how we are executing our project in phases.
All
Thank
right.
you.
Thank you, everyone. So there is a few questions in the chat, and I don't know if you'd be able to answer them, but I will still give it a go and ask them. So the first one says, how can an undergraduate student in astrophysics find opportunities to collaborate with researchers on remote projects? And they say that an interesting one is Cloud9 halo detected by the radio telescope in China, confirmed by Hubble data, and astonishing discovery. They're very passionate about this and would be looking for any opportunities that are available. Do you have any thoughts on that? It's okay
May
to
I?
also say no. Yeah,
Yeah,
you can go for it.
Okay, so because my daily job is to supervise undergrads and my PhD students, I co-supervise PhD students. So in terms of these, is kind of a popular question, I would say. And one strategy is if you are not shy at all, email them. That's the strategy one. And of course, you can use citizen science projects as a platform. So every citizen science project nowadays have a talk board or a discussion board. So please feel free to use them and add researchers of these team, and then they may potentially contact you back and start some collaboration. So that's one thing. More practically, you may try to contact your local faculties. I would say that's more practical. If there is any one local faculties or one astronomers do know that you have potential, uh, he or she may be happy to contact for you for some senior people or some multicultural collaborators, and that's what I did here. And I believe people around this room are happy to do similar things too. Yeah.
yeah.
Okay, and then there's another question from Daniel about regarding astronomy education in developing countries. So it says, in contexts like ours, where astronomy education is almost non-existent, what practical strategies can be used to convince governments of the importance of integrating astronomy into the national high school curriculum?
Yes. Yes,
So
that's very difficult. Yeah, Faisal, go ahead.
no, as Eleni, you start, then I can add on.
I would be very interested in your point of view because I could use it to convince our local government. It's a very good question. I think it comes from building the momentum So you need to, the teachers, they need to bring this topic in schools. Like we do, we collaborate with teachers in schools in our local countries. And when the momentum builds, then you can say, look, there is a lot of interest. This actually provides educational value, and it creates, it builds the bridges that we need to send people to their next level. What are they going to do as a job, right? It's not just theoretical, it's a practical education. It creates career paths. So you really need to build this in collaboration with the local educators and people that have influence in your local governments. It needs a lot of effort, and you need different types of people. In the sense of professional astronomers, educators, and policymakers. Yeah.
Yeah.
And also,
So
it's very important to clarify that we are not replacing core science education with astronomy. We are trying to strengthen the science education with astronomy. We are using astronomy as a gateway to STEM education. We are not like introducing an other luxury subject. Okay, study astronomy. So yeah, but it's not easy. It's bureaucratic thing because I have been doing these things for past few years. So when you are like offering a training, it's not like, okay, this is a training for students and teacher is free and you can join us. We have to like follow several procedures or protocols to contact the Ministry of Education and the Education Department and get the approval, and then the things go smoothly. So yes, it's not that
yeah,
easy.
adding to the points, like, so I had an experience like in 2017. I had tried to connect with here's the National Center of Physics, and we tried to propose for telescope there. And at the same time, I wrote an article in 2022 about radio astronomy. So I was contacted by SKA team. I'm part of the SKA collaboration to have meetings with the Pakistani team, Pakistanis, institutions, and then we can start talking about the collaboration. The main theme which came from the meetings with the government institutions and is that when they go for funding to the ministries and stuff, they say that, okay, whether we should apply use some the money for development for something that can be visible in the media, or if it is like which will give it, of course, the votes, and or should we apply in a community in radio astronomy or astronomy where we have a limited community. So first thing which came to my mind is to, like, although I was teaching courses in STEM education in universities, but realize in order to have a broader base, we need to have outreach programs. So when Radio Galaxy Zoo and they were doing a really good job. So I thought, like, having to trying to connect them with people in Pakistan here. That's where all this effort, even the radio project effort, is now a part of that strategy to create a base of sort of interest in the general public, so that once they are interested in that, then it will be attractive for the policymakers to invest in that for more visibility about their efforts in the country. So we need to strategize based on the different local needs, but the common thing is, like, policymakers want visibility of their contributions, of course, for the next elections. And plus, as this Hira and Eleni emphasized, that STEM, we get a lot of side skills, or a lot of skills which students learn, which can be used in STEM and industry. So these parts also needed to be highlighted. Especially like radio astronomy research is also used in telecommunications. A lot of wireless technologies have emerged from radio astronomy. So these are the things which needed to be explained to policymakers, why if you are working in a science advocacy, not just do it in classrooms or in outreach programs, write in newspapers, and which the policymakers read. That can be done. Plus, we can start with low-cost projects. Like, if we can't, of course, like China has a fast radio telescope project, or there's a SK. Not every country can do, but smaller countries with limited budgets, smaller economies with limited budget, it can start with, let's say, a single antenna for studying the solar system objects for a start. That's where we have worked with some of the universities to start some small projects where, as simple as, getting a basic signal, not a basic signal, or studying the solar objects. But once the results will start come and the community will build, then the policymakers will be, attracted more towards it and, reap the benefits out of it.
Yeah, I think it's almost like you have a top-down approach as well as a bottom-up approach. So you have to do it on both ends, hoping that at some point these two will meet and they will find common ground where they realize the importance of such initiatives, but at the same time, you already have started, you've built the groundwork, so it's easier to implement when you finally have the policies ready to implement this. So I definitely agree with you that you have to try both sides and see where the two will meet at some point. So there was another question, but I think this one was probably answered where they're asking if similar seminars were initiated regarding this project in the Philippines, but you've already stated that it's been in Greece, China, and Pakistan. So I'm assuming if you are interested in having something like this in the Philippines, you should just reach out to the project leaders and they can see how they can work with you to have it done in the Philippines as well. And then, so everything else has been addressed in the comments. And yeah, they've all of the speakers have also left their LinkedIn links so you can connect with them on LinkedIn. But there's also a question here saying that there's someone who's an undergraduate student, physics student in Namibia. How can young scientists engage in science diplomacy without being in formal policy roles? And I think this is very important for a lot of scientists because they just believe that because they're scientists, they don't belong in policy platforms. But then, so how can you engage in science diplomacy and still not be a politician, I guess?
Yeah. I think I would like to say something. We are not working at policy level. We are scientists and we are not solving political issues here, but we created this space where anybody who has the interest to explore the universe can come and join us. And we don't center the differences here. We know that differences remains always, but we don't center our focus on these differences. We focus on the shared interest, the shared language of this universe, astronomy. So the thing that I would like to mention that we are not working at the policy level, but we are working at the grassroots level. Like for example, we are working in education. We are developing international collaborations. We are trying to address the global challenges with this international collaboration. We are sharing our expertise, our knowledge. We are building this modern Silk Road, and we are the like transporters of our knowledge and our skills. So you cannot see instant effect of all of this in policy, but we are creating the social fabric that is important for future policies. So I think this is our contribution.
Yeah, so I'm noting the time and we're coming closer to the end of our hour. So I would like to ask each of you to summarize your thoughts and and anything you'd like to share with everyone in a minute, and then we can conclude today's session so we don't keep everyone waiting longer than they already need to. I'll start with you, Eleni.
Okay, great. I would like to say that this project has been a great opportunity to share my love for astronomy and science in all levels, right? And to collaborate with people that share the same love for astronomy because we really enjoy what we do. We do it with passion, and we really want to bring more students, more people to this beautiful, beautiful science because we can see not only that it's it's for discovering the universe, for me, it's that, discovering the unexpected, solving puzzles. But for other people, it provides other things, maybe friendship, maybe an occupation. So there are a lot of thoughts behind it. For me, it was excellent. I'm really looking forward to finalizing the current project and continuing it this is the goal for the future, continue this project for the future. Thank you.
Hongming, I feel like Hira's still sending a lot of messages.
Okay, yeah, I can do that. Yeah, think that astronomy in the last few years actually paved me the way to know people and let people I met know each other. So I think through these projects, not only students but teachers and some level policymakers got chances to talk to each other through astronomy, and I think it's a really precious opportunity for all of us. And I personally hope that this can be a starting point for a very long term, large collaborations across the borders, of course, and across cities to villages and so on. I would like to share one final example. We took 30 years to get fast built in China. And nowadays, the Guizhou province that built fast prioritized astronomy education because they knew the benefit of building such an instrument. Thank you.
Yeah, Faisal?
Yeah. So I would just like to focus again on the importance of, learning as much as you can from wherever you can possible. So from these projects, we can, start, give you a jump start. But then again, you can do a lot. Like I was seeing the questions about the undergrad students, where to start. So one way, to start is to use a lot of the data which is publicly available. A lot of science surveys data is publicly available, so you can do some science using that and promote it in your if you publish it, then share it in your own language, the outcomes in the brief outcomes of the study, and then that will create awareness about, okay, something can be done without a lot of resources based on the whatever public data is available. So that's what we are trying to, one of the things which we are doing as part of this is not teaching programming, and at the same time tools like Aladdin and Stellarium, where people, not only science hobbyists can get images and data through this platform, but even in Aladdin you can download catalogs where you can do a lot of good science as well. So be curious, stay curious, and try as to find as much publicly available data and try to play with it, and hopefully somebody will along the way come and help you out and be a part of your learning journey as well, and then you will have a team and a community which you can work collaboratively for different skills of the project. So yeah, just keep learning.
And Hira.
And you can always join citizen science project like Radio Galaxy Zoo.
All right, thank you so much, everyone. So yeah, just to wrap up today's full moon mashup, I would like to start off firstly by saying that I left a few links on our in the chat. So one of them looks at how you can join our online community where you can continue having these discussions with other people within the space. And then the other one is if you're interested in joining our mailing list, so you can get updates from the OED. So we've recently announced the projects that we'll be funding in 2026. And the next call will be open in April. But also, I'd like to extend the invitation to our presentation day for the 2025 project. So if you want to hear more about radio again, you can join us next month on the 20th to get feedback on updates about their project and how the year had been for them. But otherwise, to wrap up today's session, I'd like for us to take a moment to reflect on what we've heard and also discussed, and also just take this conversation with us as we approach the year ahead of us. I mean, with everything that's happening around us currently around the world, it is very important to sort of kind of see the importance of being able to come together through science. And astronomy serves to be one of those points where we can actually gather together around that. So, yeah, I'd like to extend my sincere thank you to our speakers for sharing their experiences. I mean, we always think an hour is too long, but once you start these conversations, you realize that an hour is actually not long enough. So we try to get as much as we can discussed in this hour, but unfortunately, we have to stop now. But yeah, thank you so much for joining us today, and everyone else who did join us, thank you so much. If you are interested in proposing a topic or just being our next guest speaker, we do this monthly, roughly around the full moon. So if you look at the calendar and you see when the full moon is, it's normally the Friday closest to the full moon. So you can either propose a topic or just volunteer yourself to host a session or join me in hosting a session so we can have these discussions. And yeah, with that said, I'd officially like to end this conversation and thank you so much for joining us today. And yeah, stay connected with us through our various social media platforms, our mailing list, as well as our online community on Discord. And yeah, we'll hope to have you guys join us in the next session. Thank you so much for joining today.
Thank you very much.